Okay, so in this tutorial video, which is tutorial for your second test on linear algebra, the 20% linear algebra test, you'll be given the Summer 2020 question 1. Now you'll be given an hour and a half to do the questions and also to submit your work. Now it's about 42 minutes worth of marks, and that is 35% of the paper, of the final paper. But it can be a long question as they go. Like the Laplace would probably be quicker. So time, it appears you've loads of, you've got 48 minutes extra, but you haven't got all the time in the world, but you should have time to check your answers. And we'll just describe briefly how you could do that, maybe the easiest way to do it, and then go a bit further. Okay, so question 1, there's a story about whatever it's talking about there. It's talking about 3D laser scanning, and you end up with these 3 equations and 3 unknowns, A, B and C, and it's asking us to use Gauss elimination to find the values of A, B and C. Now it should be no problem for you to write these in what's called Augmented Form. So we have 1A minus 2B, minus 2 times B, rusty on these, plus 1C equal to 8. 2A minus 1B plus 2C is equal to 10, and finally 3A minus B plus 2C is equal to 11. Now if, for example, it turned out that this was the first equation and this was the third equation, you're perfectly entitled to swap rows 1 and 3. But I'd probably say that, like I always have done it the same way in the notes, that we get 1, 0, 0, 1, 0, 1. I'd recommend that you do it that way, apart from perhaps swapping rows. Okay, so we've got our 1 here, that's our pivot, that's good. And then we're going to use that pivot to kill the 2 things underneath. So we're going to do row 2 sent to itself. Well, it's always going to be sent to itself, so maybe let's write what this is going to be sent to. Row 2 minus twice row 1, and this one we're going to do row 3 minus 3 times row 1. You'll want to do some exercises, just get your eye in, that you're comfortable that there's 3 row operations again. Okay, so let's see what we get. First row is good, 1 minus 2, 1, 8. 2 minus twice 1 is equal to 0. Minus 1 minus twice minus 2 is minus 1. Plus 4 is equal to 3. 2 minus twice 1 is equal to 2 minus 2 is equal to 0. 10 minus twice 8 is 10 minus 16, which is equal to minus 6. 3 minus 3 times 1 is 0. Minus 1 minus 3 times minus 2 is minus 1 plus 6, which is 5. 2 minus 3 times 1 is equal to minus 1, and 11 minus 3 times 8 is 11 minus 24, which is minus 13. So now we have pivot, first column is done. Next thing is to turn this into a 1, and what you need to do there is send row 2 to itself, divided by 3. So we have 1 minus 2, 1, 8. 0 divided by 3 is 0, 3 divided by 3 is 1, 0 divided by 3 is 0, minus 6 divided by 3 is minus 2. And now we want to turn this 5 into a 0, and we'll use this pivot here. So you're making pivots, and you're using the pivot to kill everything underneath. So 1, 0, 0. Made this into a pivot, and now we'll use this pivot here to attack the 5 underneath. So we're going to do take away 5 times the new row 2. So I'm going to do row 3, take away 5 times the new row 2. And I just put a dash there in case I want to look out the window for a while and come back to it. So 0 minus 5 times 0 is 0. 5 minus 5 times 1 is 0. Minus 1 minus 5 times 0 is minus 1. And minus 13 minus 5 times minus 2 is equal to minus 13 plus 10, which is minus 3. And then we've just got one more row operation to turn this into a pivot. I can either multiply it by minus 1 or divide it by minus 1. They're actually the same thing. So we end up with, writing a bit neatly now, 1 minus 2, 1, 8. 0, 1, 0, minus 2, and 0, 0, no, 0 divided by minus 1 is 0, 0 divided by minus 1 is 0, minus 1 divided by minus 1 is 1, and minus 3 divided by minus 1 is 3. And now you've completed the Gauss elimination. Now, you're not finished, of course. We're looking for A, B, and C. So to analyze it, you look at the pivots. And even before that, you say, are there solutions? Now, if there's 0, 0, 0, 0, non-zero, there are no solutions and you're done. After that, you look at the pivots. And you say, is there any pivotless column? No. And then there's no parameter. So that means here there's a unique solution. So let's start writing it down. The third row here says that C is equal to 3. Okay, the dog has joined. Hopefully he won't be making any noise. So C is equal to 3. Then the next row down, now at this stage you should be able to, like, this is B plus 0C is equal to minus 2. You should be able to do this a little bit faster than before. So this should just be, well, this one is easy. B is equal to minus 2. And then the last one, A minus 2B plus C is equal to 8. So what I'm going to do is A is equal to 8. This is minus 2B, so add 2B to both sides. And then this is take away C, which is 3. So I get 8 minus 4 is 4 minus 3, I get 1. So I get A is equal to 1, B is equal to minus 2, and C is equal to 3. Now you have to ask yourself some questions. Have I answered the question that has been asked? Did I use Gauss elimination to find the values of A, B, and C? Yes, I did. Now, does my answer make sense? Now what you can do here is you can actually substitute the values into the equations, and I recommend that you can substitute into all of them, but definitely don't substitute into the top one. There's absolutely no point just checking the top one, because if you look at what this is, no matter what B or C is, you'll find an A that solves this. So what you need to do, if you're going to check your answer, if you're not going to check all of them, just check the last one. So if I check the last one here, I get 3 times A, which is 3 times 1, minus B, which is minus 2, plus 2 times C, which is 2 times 3, and see what do I get? 3 minus 2 is 5, plus 6 is equal to 11, and that's a good check. Maybe you can check all your answers. You've got 90 minutes. If you check them to this degree and you've still got more than 15 minutes left, it's probably worth checking the other ones, although it's very unlikely that it solves the last one and not all of them, but it could be worth checking. Okay, so we're going to go on now to question B. In a second, the dog needs attention again. Okay, we're back again, sorry. Alright, on to question B. So in question B, we have a UDL over a beam. Have we got some unknowns here? Yeah, we've got two. You're going to want to have the exam paper open. It's at the back of your manual to follow this. So there's two unknowns. There's a reaction R1, there's a reaction R2, and the load per unit length factor is also a variable. It talks about the beams, etc., but at the end of the day it just gives us some equations, and it wants us to find the solution of the linear system. So if I do that, I see, so this is question B. I see 1 R1, 1 R2, minus 6w equal to 0, and I see 0r1, 6r2 minus 18w equal to 0 also. Okay, so we want to get into augmented form. Now thankfully first column is good, pivot 0. What we want to do next is turn this 6 into a 1. You do that by dividing by 6. So we're going to send to row 2 divided by 6. 1, 1 minus 6, 0. 0 divided by 6 is 0. 6 divided by 6 is 1. Minus 18 divided by 6 is minus 3. And 0 divided by 6 is 0. We're now in reduced form. So I have pivot 0, pivot 0. We can't do any more. Are there solutions? Yes, because we don't have 0, 0, 0, non-zero. What about pivots? Well, R1 is has a pivot, R2 is a pivot, W does not, so you can choose W to be a parameter. Pivotless column W can be any value at all. Okay, so now let's do the rest of this. So this is R2 minus 3t equal to 0, so add the 3t to both sides and you get R2 is equal to 3t, and the other one here you get R1 is equal to R2 minus 6w is equal to 0. Add the 6w to both sides, that's 6t. Take away R3, so you end up with R1 is equal to 6t minus R2, which is minus 3t, so you get 3t. So the solution is R1 is 3t, R2 is 3t, and W is t. Okay. And the next question is find the solution if W is equal to 10. I'll just throw that down here, there's plenty of room. So if W is 10, that means the value of the parameter is 10. And so you get R1 is equal to 30, R2 is equal to 30, and W is equal to 10. Okay. That's that question done. Now, have we answered the question that's asked? Did we find the solution of the linear system in terms of parameter t? We did. It's not written all together, but it's there. Does our answer make sense? What we can do is we can substitute in. Again, I recommend substituting into the last equation. So you get 6 by R2, that's 18t, minus 18 by W, 18t minus 18t is 0. That works. So in that sense, your solution makes sense. What about the second question? Does your solution make sense? That R1 is 30, R2 is 30, and W is 10. If you go back and look at the original problem, what we're talking about is a beam of span 6. And if W is 10, it's 10 kilonewtons per meter by 6 meters. That's 60 kilonewtons. And the R1 and the R2 must balance that. So the R1 and the R2 must add up to 60, and they do. And there's perfect symmetry, so they should be equals. So that's what I mean by saying that the answer makes sense. Okay, let's look at question C. Now there's lots of different questions that can come up in this. There's a fairly wide selection of questions. Obviously, basically anything in chapter 1 of your manual is kind of game to be asked. Okay. So it's not just going to be like, oh, there'll be a question exactly like this. That's not the case. Okay, so again, this is on page 225 now, this question. Page 225 your manual. As plotted below, the lines, so there's two lines there, 0.001x plus 1y equal to 1.001, and there's 0x plus 1y equal to 1. And basically, yeah, you have the picture in front of you, they have a unique intersection. Part 1 of this question says, if the 0.01 is rounded to 0 and the 1.001 rounded to 1, then the linear system has a certain different form. And the first question here is, use Gauss elimination to find the solution of the linear system. So what do we have? We have 0x plus 1y equal to 1 and 0x plus 1y equal to 1. Now you cannot in this case form a pivot in this first row, unfortunately. but this is a pivot. And so you want to, everything underneath it turn into a 0. So I want to do row 2 minus row 1. And if I do that, I get 0, 1, 1, 0, 0 minus 0 is 0, 1 minus 1 is 0, 1 minus 1 is 0. Question, does this have solutions? Yes, there's no 0, 0, non-zero, so it has solutions. Look at the pivots, there's one pivot, and the pivotless column, which is x, can be anything. X is a parameter. And then, well, this just says 1y is equal to 1. Okay, so that's the, any x can be anything and y just has to be 1, and it'll be a solution of this linear system. Explain this result geometrically. Now you can go off and kind of plotting and stuff, but ultimately this represents two lines and this is their intersection. There's two lines that intersect at infinitely many points. It means they're the same line. So all we have to do here is just say that same line. You can draw pictures, but ultimately it boils down to the fact that these equations, the equations are exactly the same. So there isn't actually, there's two lines, but they're both the same because they have the same equation. Okay, that's that done. Not too bad. Second one, if only one of these numbers is rounded, then the linear system looks a little bit different. Use Gauss elimination to solve this system. So this one is 0x, 1y equal to 1, and 0x, 1y equal to 1.001. Similar story as above. You can't make any pivot here, so that's out. This is a pivot, you need to kill this thing. So you want to do row 2 minus row 1 as before. 0 minus 0, 0 minus 0 is 0, 1 minus 1 is 0, and 1.001 minus 1 is 0.001. And the question here is, okay, find the solution. Well, this says 0x plus 0y, which should equal 0, equals something non-zero. This has no solutions. Now we can go back. It says explain the result geometrically. You can go back and kind of draw what happened. So there's two lines originally that were very, very close together, something like this, and they had a unique solution. In the first one, the two roundings made the two lines the same, exactly the same line. In the second one, the rounding was a little bit different. So remember, originally you had this, and the rounding actually made it go like this. And what that means is that the lines are now actually parallel. But you didn't have to know that, because all you have to know is, okay, you're finding two equations and two unknowns. Solving that is finding the intersection of two lines, and there's no intersection. The only way that can happen is if the lines are parallel. Not sure if that's spelled right. Okay. Have we answered the question I was asked? Yes, we use Gauss elimination to find the system, solve it. We use Gauss elimination to solve it. Did we explain the result geometrically? Yeah, we said they're the same line. Did we explain the result geometrically? We said the lines are parallel. Then, third part, hence, comment briefly on rounding in the context of linear systems. Okay, so the rounding that was involved was in the third and fourth significant figure. In the third decimal place, we rounded 1.001 to 1 and 0.001 to 0. So these numbers are very, very close together. But one of the things I've tried to drill into you is that rounding, while it can be safe sometimes, like saying, oh, pi is approximately 3.14, is that there are, those rounding will cause errors in your calculations. That's kind of what we were looking at last semester. But it's particularly important when you're doing linear systems, in particular when you're doing Gauss elimination, that it's very, very susceptible to rounding error, and it's basically not safe. So here we're going to say not only can rounding change the solution, it can change it dramatically. The original problem had a unique solution. One type of rounding gave it infinitely many solutions, each value of t gave you a solution. Another rounding gave you no solution. So what we're going to say is that, hence, comment briefly, we're just going to say that rounding can change answers dramatically. Solutions. Rounding can change solutions. So I could even say here, the nature of the solutions. It's changed from unique to infinite and unique to none. But it's just looking for a brief thing, so I'm going to say change solutions dramatically. And you should know that if I ask you to do linear systems, do some Gauss elimination with rounding, you have to do partial pivoting. Okay, that's that question done, we're getting there. Question D, we're given a roundabout given by a traffic flow diagram. Okay, so the first thing is write down